Hello everyone, my name is Subham Joshi and I'm a third year integrated MSc Physics student of IITR. This video is a part of our Corona lockdown assignment under Professor Mayank Goswami for our course Microprocessor and Peripheral Devices, PHN 340. In this video, I'll be talking about how a microprocessor understands a high level code. Let's get started. What is the difference between a high level and a low level code? Let's start with a high level language. A high level language is a programming language that enables a programmer to write programs that are more or less independent of the type of computers. These programs can be run in more than one type of machine. Such languages are considered high level because they are close to human languages. Like for example, here we have written a simple hello world program in two languages. This is Python and this is C. These programs are written in English. Advantages of a high level language. The main advantage of a high level language over low level language is that they are easier to read, write and maintain. Ultimately, these programs can be compiled for various machines. Now, what is a low level language? A low level language is a programming language that is very close to actual machine instructions. Example are machine code. Here this is written in hexadecimal, and assembly code, the corresponding mnemonics which are written here. We all know machines understand binary and we humans understand English or Hindi or various other languages but not binary. So the question is, how do we communicate our instructions to a machine? Well, the answer seems simple. Just code. We generally write a computer program using a high level language. A high level language is a language that can be understood by us, humans. This code is called as the source code. However, a computer does not understand a high level source code. It only understands a program written in binary, that is, in the machine code. Let us create a hello world file and try to understand what happens under the hood while executing this program. We will create this program and see the intermediate file. This is a hello world C program. We compile our hello world file to see the following on screen. This file has been compiled using GNU GCC compiler. This is a compiler for C language, and I saved all the temporary files. These files were made when our high level text file written in C, that is world.c, was compiled to our low level binary output world. What are these three files? Let us understand by understanding what goes inside the compilation process. The compiler converts the program into an executable program. We all know that. There are four phases for a C program to be converted to executable machine code. These are first preprocessor, second compilation, third assembly, and fourth linking. Preprocessing. This is the first phase through which our source code is passed. In this phase, comments are removed, macros are expanded, and the included header files are also expanded. The pre-processed output is stored in world.i. Let's see what's inside world.i using vi editor using command vi space world.i. So we can see the header file is being expanded. And this is our main program which is being as it is. And we can see here where we have written our comment, this has been removed. Now the next step is to compile the file world.i to produce an intermediary compiled output called world.s. This file is an assembly level. Let's see this file using vi text editor. This snapshot shows that a hello world program has now been converted to assembly language which the assembler can understand. Assembly. In this phase, the world.s file is taken as input and is turned into world.o file by assembler. This file contains the machine level instructions. Let's open this file using vi editor. Here we can see it cannot be read by us since it's in machine language. Linking. This is the final phase in which all the linking of the function calls with their definitions is done. Linker knows where these functions are implemented. linker does some extra work also. It adds some extra code to our program, which is required by a program to start and end. For example, there is a code required for setting up the environment and passing argument lines. Let me explain how a microprocessor works. The processor contains the circuitry to do a number of operations like addition, subtraction, comparison, etc. But the correct circuitry only get connected when the corresponding instructions get fed into the microprocessor. For example, the opcode ATH in 8085 corresponds to add B, which means that the bit stored in register B is added with the bit stored in the accumulator. The ones and zeros in the instruction ATH causes the transistors inside the processor to open and close in such a way that accumulator and register B gets connected and the result of the addition gets stored inside the accumulator itself. Let's summarize our discussion. So as to make computers understand our command, our code goes through a process to convert our English typed alphabets to machine code. This translation follows the following hierarchy, which is shown in the screen. Our code is first translated to assembly language by the compiler, which in turn is translated to machine language by the assembler. This code instructs the processor to do the required task. Today, life cannot be imagined without a microprocessor. Just imagine a life without any cell phones, no games, no internet, no communication, no online education, nothing. It's hard to imagine. It is no doubt to say that the invention of powerful computers lies microprocessors at the heart. And this microprocessor is driving the 21st century revolution. Thank you.